Question 1, Paper 12, May-June 2025. We describe how one graph transforms into another. Two curves are given, y equals f of x and y equals g of x. Find two transformations that take f onto g, stretch, then translate. Compare the two graphs on the same axis. Sketch f, peak at 0, flat plateau from 3 to 8. G has the same x shape but different heights, no horizontal shift. Peaks still at x equals 0, the flat section is unchanged in x. Peak height goes from 3 to 6, vertical stretch, factor 2. Solve G equals AF plus B at 2 points, A is 2, B is minus 14. Apply the transformations step by step, starting from F. Step 1. Stretch parallel to the y-axis, scale factor 2. Step 2. Translate by 0, minus 14, shift the graph down. The result matches G exactly. G of x equals 2f of x minus 14. Answer. Stretch in y by factor 2, then translation 0, minus 14. Order matters, stretch first, then translate. Equivalently translate minus 7 first, then stretch. Question 5, Paper 12, October-November 2024. A rational function, its inverse, and a composite equation. F of x is 2x plus 1 over 2x minus 1, with x less than 1/2. G of x is 3x plus 2, defined for all real x. Part A, Part 1, evaluate f at minus 1. Substitute x equals minus 1 into the fraction. Numerator minus 1, denominator minus 3. Simplify to 1/3. So f of minus 1 equals 1/3. Part A, Part 2. Sketch the inverse by reflecting in y equals x. Draw axes and the branch of f for x less than 1/2. Here is y equals f of x. Add the mirror line y equals x. Reflect the curve across the diagonal to obtain y equals f inverse of x. Reflecting in y equals x swaps input and output, that is the inverse graph. Part A, Part 3. Find f inverse and its domain. Swap roles. Let y be the output and solve for x. Rearrange the algebra step by step. 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 Swap x and y to write f inverse of x equals x plus 1 over 2x minus 2. The domain of f inverse equals the range of f. Write f as 1 plus 2 over 2x minus 1. Since x is less than 1/2, 2x minus 1 is negative. So 2 over 2x minus 1 is negative. Hence f of x is less than 1. The range of f is all values strictly below 1. Therefore the domain of f inverse is x less than 1. Part B. Solve f of x equals g of f of 1/4. Recall g of x is 3x plus 2. First evaluate f at 1/4. Then apply g to get minus 7. So we need f of x equals minus 7. Solve the rational equation on the right. Cross-multiply and collect x terms. Continue simplifying. Continue simplifying. Continue simplifying. Continue simplifying. X equals 3/8, which is less than 1/2 valid for the domain. Summary of the main results. Collect the 3 key answers. AI. f of -1 is 1/3. A 3, f inverse with domain x less than 1. Bx equals 3/8. Question 5, Paper 13, October-November 2024. Graph transformations from f to g. Here are the given graphs on the same axis. Solid curve y equals f of x, dashed curve y equals g of x. Part A asks for 3 transformations, Part B for g of x equals af of bx plus c. We will map f onto g step by step, then read off a, b, and c. Part A. Describe 3 transformations that take f onto g. Track the shape with a working copy and the key vertices. Step 1. Reflect in the y-axis, so x becomes negative x. The curve becomes y equals f of minus x. Step 2. Translate 1 unit in the negative x direction. Now y equals f of minus x minus 1. Step 3. Stretch parallel to the y-axis with scale factor 2. This gives y equals 2f of minus x minus 1, which is g of x. The transformed f matches the dashed graph g. Part B. Write g of x as a times f of bx plus c. Keep the graphs on the left while we read the parameters from the transformations. Start from the template g of x equals af of bx plus c. A is 2 from the vertical stretch. B is -1 from reflecting in the y-axis. C is -1 from translating 1 unit left. So g of x equals 2f of minus x minus 1. Summary of the transformation chain and final formula. Reflect, translate left, then stretch in y by factor 2. Reflection in the y-axis. Translation -1 in x. Vertical stretch times 2. Final answer, g of x equals 2f of minus x minus 1. Question 8, Paper 13, October-November 2024. Complete the square, restrict the domain, find an inverse, and solve a composite. F of x is 3x squared minus 12x plus 14, defined for x at least k. Parts A through D, square form, least k, inverse, and f of x equals 29. Part A. Write the quadratic in completed square form. Start with 3x squared minus 12x plus 14. Factor 3 from the x terms. Complete the square inside the bracket. Expand the minus 3 times 4. So the vertex form is 3 times x minus 2 squared, plus 2. Matching 3 times x plus a squared plus b gives a equals minus 2 and b equals 2. Part B. Find the least k so f is 1 1 and f inverse exists. Sketch the parabola 3 times x minus 2 squared plus 2. The minimum is at the vertex 2, 2. Mark the turning point. A horizontal line can meet the curve twice f is not 1 1 on the full parabola. Restrict to x at least 2. Keep only the increasing right branch. Now each y value is hit once. The least k is 2. Part C. Find f inverse when k equals 2. Set y equal to f of x and solve for x. Rearrange step by step. Rearrange step by step. Rearrange step by step. Rearrange step by step. Because x is at least 2 on f, take the positive square root. So f inverse of x is 2 plus root x minus 2 over 3, with x at least 2. Reflect f in y equals x to see the inverse graph. Draw f on x at least 2 and the mirror line. The reflection is the graph of f inverse. Part D. Solve f of x equals 29. Apply f inverse twice x equals f inverse of 29. Use the inverse formula from Part C. First, f inverse maps 29 to 5. 2 plus root 27 over 3 is 2 plus 3, so 5. A second f inverse takes 5 to 3. So x equals 3. Check, f of 3 is 5, and f of 5 is 29. Summary of all 4 parts. Collect the key results. A. 3 times x minus 2 squared plus 2. B. Least k is 2. C. F inverse with x at least 2. Dx equals 3. Question 10, Paper 13. Stationary points and graph transformations. The curve is y equals 9 over 2x minus 5, plus 2x minus 5. This rational plus linear term has 2 branches. Start from the given equation. Differentiate. Chain rule on 9 over 2x minus 5. Set dy by dx equal to 0, 2x minus 5 squared equals 9. So 2x minus 5 is plus or minus 3, x is 4 or 1. Substitute back. Y is minus 6 at x equals 1, 6 at x equals 4. The stationary points are 1, minus 6 and 4, 6. Sketch C with vertical asymptote x equals 5 halves and oblique asymptote y equals 2x minus 5. 2 branches. At 1, minus 6 we label a local maximum, at 4, 6 a minimum. Lower y can still be a max on a branch. Part B. Second derivative 72 over 2x minus 5 cubed. At x equals 1 the second derivative is negative, maximum. At x equals 4 it is positive, minimum. Part CI. Translate minus 3, 7, then reflect in the x-axis. Translation moves the extrema, reflection swaps maximum and minimum. The maximum of C1 is 1, minus 13. Part C2. Replace x by x plus 3, add 7, then negate y for the reflection. C1 is y equals minus 9 over 2x plus 1, minus 2x minus 8. Summary. Stationary points, second derivative test, then transform to C1. Question 11, Paper 11, October-November 2024. Quadratics, transformations, and inverse functions. We work with f on the real line and g on the left branch where x is at most 0. F is the full quadratic, g uses the same formula but only for non-positive x. Part A. Rewrite f in completed square form. Start from 3 plus 6x minus 2x squared. Factor negative 2 from the quadratic part. Complete the square inside the bracket. Expand the negative 2 through the bracket. So A is 15 halves, B is 2, and C is 3 halves. The parabola opens downward, so the maximum is 15 halves and the range is f of x less than or equal to 15 halves. Sketch F. A downward parabola with vertex at 3 halves, 15 halves. The curve peaks at the vertex. Mark the vertex and the horizontal maximum line for the range. Vertex, direction, and range, f of x is at most 15 halves. Part B. Start from y equals f of x, then apply 2 transformations. First, reflect in the x-axis, replace y by negative y. The maximum becomes a minimum below the axis. Then translate by -3/2 in x and +15/2 in y, moving the minimum to the origin. The image is h of x equals 2x squared, opening upward from the origin. So h of x is 2x squared with its minimum at the origin. Part C. Restrict to x at most 0 and explain why g is 1, 1. The full parabola has a turning point at x equals 3/2. On x at most 0 we keep only the increasing left branch, that is g. The turning point at 3/2 lies outside the domain, so g does not fold back. 3/2 is not in x at most 0, so g is increasing and therefore 1, 1. Each y value is hit once on that branch, that is what 1, 1 means here. Part D. Reflect g in the line y equals x to obtain g inverse. Here is g on its domain. Draw the mirror line y equals x and reflect the graph across it. The inverse curve swaps the roles of x and y. Label the inverse function. The point 0, 3 on g maps to 3, 0 on g inverse. Write y in completed square form and rearrange for x. Square root gives plus or minus. Because x was at most 0 on g, take the negative root. That yields g inverse of x, 3 minus root 15 minus 2x, all over 2. Box the final inverse formula. Summary of all four parts. A. Completed square and range f of x at most 15/2. B. Reflect then translate, h of x is 2x squared. C. G is 1, 1 on x at most 0. D. G inverse with domain x at most 3. Remember, the left branch forces the negative square root when you invert g. Question 11, Paper 12, February-March 2025. Composites, transformations, and range. F and g are given, with g inverse of 3k plus 1 equals c. G inverse of 3k plus 1 equals c means g of c equals 3k plus 1. Substitute g, 2c plus k equals 3k plus 1, so c equals k plus 1/2. G of f is 2 times f plus k. Substitute f equals 4x squared minus c. Expand to 8x squared minus 2c plus k. Use c equals k plus 1/2 to get gf equals 8x squared minus k minus 1. Part B. Start from gf. Translate 2, 3. Replace x by x minus 2 and add 3. Stretch in y by factor k. Reflect in the x-axis. Replace y by minus y. H of x is minus 8k times x minus 2 squared, plus k squared minus 2k. Part C. H has maximum 15 at x equals 2 when k is 5. Set k squared minus 2k equal to 15, k equals 5, so c equals 11/2. Summary. C in terms of k, composite gf, transformed h, then k equals 5 and c equals 11/2. Question 11, Paper 12. Completing the square and inverse functions. F on the left branch x at most minus 2, g on x at least minus 2. Part A. Complete the square for x squared plus 4x plus 2. Half of 4 is 2. X plus 2, squared expands with plus 4, subtract 4. So x squared plus 4x plus 2 equals x plus 2 squared minus 2. Answer, A equals 2, B equals minus 2, vertex at minus 2, minus 2. F is the left branch only, domain x at most minus 2, range at least minus 2, so F inverse exists. Invert f. Start from y equals x plus 2 squared minus 2. Add 2. Square root gives plus or minus. Domain x at most minus 2 forces the negative root. F inverse is minus 2 minus root x plus 2. F and F inverse are reflections in y equals x. Swap coordinates on a sample point. GF means apply f then g. GF of x is minus f of x minus 4, which simplifies to minus x plus 2 squared minus 2. Invert GF the same way. Negative root because x plus 2 is non-positive. Add 2. Multiply by minus 1. Take the square root. GF inverse is minus 2 minus the square root of minus x minus 2. Summary. Complete the square, F inverse, then GF inverse always the negative root on the left branch. Question 11, paper 13. Range, completing the square, and composite functions. F is a quadratic in x. G inverse is the cube root of 2x minus 4. Part A. F equals x squared plus 4ax plus a. Complete the square x plus 2a squared, minus 4a squared plus a. Minimum value is a minus 4a squared at x equals minus 2a. Range f of x greater or equal minus 33 sets the minimum to minus 33. Rearrange to 4a squared minus a minus 33 equals 0. Factorize. A equals 3 or a equals minus 11 quarters. Two values of a satisfy the range condition. Both parabolas touch the line y equals minus 33 at their vertices. Start from G inverse. Part B. Invert G inverse by letting y equal the cube root. Cube both sides. Make x the subject. Swap x and y to write g of x. Check. G of G inverse returns x. FGG of 0 equals 96. Apply g twice, then f, starting from 0. G of 0 is 2, g of 2 is 6, then f of 6 gives 36 plus 25a. So a equals 12/5. Summary. Two values of a from the range, g from G inverse, then a equals 12/5 from FGG.